my name is Sophia, and this is my Lab 2 report. So in Lab 2, we extended the idea from Lab 1, where we used household objects like tape to demonstrate electrical fields and electrical forces. Now in this lab, we also made charged tapes, but instead of treating them as a point charge, we treated them as a uniformly charged positive, as a rod with a uniform charge. And each piece of the rod generates its own little point charge and its own little electric field. And we also use Newton's second law, which I'll explain shortly. So as I alluded to on the previous slide, we had some positively charged tapes, and we made them by laying down a base tape and then putting a tape at the top of that. And then we ripped off this top tape, this upper tape, to give it a positive charge. And after that, we suspended one upper tape from a book and then brought another positively charged upper tape right under it to make this top tape float. So the bottom tape exerted an electrical force on the top tape, which made the top tape float up until the point when the gravitational force on the top tape balanced with the electrical force on the top tape from the bottom tape. And that's when tape B was in equilibrium, according to Newton's second law. And so we used this gravitational force and electric force on tape B to calculate the charge produced by each little piece of tape B and also the net charge of tape B. And so we already knew the gravitational force of tape B, or could calculate it easily, and the net electric force on tape B from tape A is equal to the gravitational force, and so we could back calculate the charge Q. We assumed that both tapes, the top tape and the bottom tape, they act as uniformly charged rods made up of many small point charges, and each piece has an equal charge, and also that the charge of the two tapes is the same, and we ignored air resistance. Charge of tape B as well as the charge of each little piece of tape B. I divided each one of these tapes into many pieces, such as 300 pieces. And so as you divide the tape into many more pieces, and you divide the net charge into many small pieces, the value of the electric field and electric force change, and they become more accurate and converge towards some value that is like the true electric force and true electric field. And so you can use this true electric field to tune your to tune the value for the tape's charge until you find the charge Q, where the electric force from the bottom tape on the top tape balances with the gravitational force on the top tape. And so I found that the top tapes and the bottom tapes charge were both 3.26 times 10 to the negative 8th coulombs. And this is larger than when I modeled the tape as point charges. And that's because if you notice here from the illustration, some of the force generated by each piece of the bottom tape on the top tape has some horizontal components. And now the horizontal components don't really do anything to counteract the gravitational force on the top tape, so you can say that they're lost, and only the vertical component of this force counteracts the gravitational force. So you need a greater charge to generate a greater vertical component to cancel with the gravitational force. And finally, I wanted to show the complete model. So here in this visualization right here, the bottom tape is blue and the top tape is red, but it's actually not visible because it's covered by these arrows, and the arrows represent the force on each piece of the top tape from each piece of the bottom tape. And then all of these green arrows are summed together to give the net electric force, which is this white arrow pointing up. And so the horizontal components cancel, as I said previously, and the vertical components sum to counteract the gravitational force. And so I measured that the gravitational force using the mass of the tape was negative 1.96 times 10 to the negative third newtons. And then the electrical force has the same magnitude, 1.962 times 10 to the 3 newtons, but it points up. Yeah, thank you for watching. Have a good day.